Okay, so hopefully you did okay with the U substitution. Today's lesson is very short because it's doing the same thing, but now it's just definite. So you're not going to have the plus C at the end. This is the one we're going to plug the numbers in. So it's going to work the same way it did before with the definite integration. It's just now you have to do U substitution. So it's kind of blending both together. That's why I only have 4 problems here. And you will need a calculator because some of the answers get a little crazy. So here we go. First, to integrate, we would have to do our U substitution. So again, you always want U to be the inside of the function. So here, U is going to be 4x squared plus 3. We'll take the derivative of that. So du is going to be 8x dx. Okay, and the 3 goes away. We know that from taking derivatives. So now looking here at my function, I'm missing the 8 in front. So just like with our lesson earlier in the week, I'm going to put a 1/8 out front. And then I'm going to have an 8 here on the inside now. And now I can rewrite using the u's. So the 1/8 will stay out front. Now the 8x dx becomes the du, and this becomes u cubed. So I have u cubed du. Now I'll integrate. So I have 1/8, and I'm going to put this in brackets, add 1 to my exponent, and then divide by that number. Now, the one common mistake students will make is that they will plug the -2 and the 1 in here for u right now. They'll take these two numbers, plug in for u, and subtract. You cannot do that. The -2 and the 1 are for when you have x's. It's pertaining to that variable. So I can't plug them in here because those still pertain to x. So before I can do that, I have to plug the u back in. Well, plug the x back in for the u. So I'm going to have 1/8 times 1/4 times the quantity 4x squared plus 3 to the 4th. And that gets taken from -2 to 1. So now we plug the 1 in. So I have 1/8 times 1/4, and then I'll plug 1 in. So 1 is going to give me 7 to the 4th. Like I said, some of these numbers are going to get a little crazy. So that's 2,401 minus 1/4. Now I'm going to plug in -2. And when you plug -2 into here, you get 19 to the 4th, which is even a more ridiculous number. So we get 130,321. And then you can plug that all into your calculator like that, or you can break it down piece by piece, however you want to. But when you're done, your answer should be -3,997.5. And if it's an exact decimal like that, you can leave it as a decimal. If you want to write it as a fraction, you can. However you want to do it, however your calculator gives it to you. Okay, so the u substitution's the same. Remember, u is the inside. Take the derivative. Then you're going to integrate. Plug that back in. And now for our previous lesson, this is where you would stop right here. This would be your final answer. But we have our numbers here for the definite integration. So I'm going to plug them in and then subtract their answers to get your final. So for this next one, if you want to give this one a try, it's just like the first one. So if you want to pause the video, give it a shot, try it on your own, and then see how you did. Or if you want to just keep following along, that's fine too. So first, u is going to be, again, on the inside. So u is x squared minus 4. Take the derivative of both sides. And good news this time, we need the 2x, and we have a 2x, so I don't have to rewrite or change anything. I can go right to plugging in the u's. So I'll have the integral of 1 to 3 u squared du. And then I'll integrate. So we'll add 1 to our exponent and then divide by the exponent. Now remember, we're not going to plug the 1 and the 3 in there to u. I'm going to put my x quantity back in. So there we go. So now I can plug those in. So I'll get 1/3 when I plug in 3. I'll get 5 cubed, which is 125, minus, when I plug in 1, I'll get -3 cubed, which is -27. And so you end up here with 152 over 3. This one I would leave as a fraction because it'll be a decimal that repeats forever. So if you do want to write it with the repeating bar, with the 0.3 and then the repeating bar, that's fine. But I think it's easier to just do it as a fraction. So that's what you should have got. 152 divided by 3. Okay. These last two, they work the same way as well. Again, if you want to try this one on your own, feel free. Pause the video, try it on yourself, or just keep following along. So first, I'm going to rewrite this integral, well, the square root, as an exponent. So I'll have 2 to 3, 6 times the quantity, 10 minus 3x to the 1/2. And now u is going to be the inside. So u is going to be 10 minus 3x. So du will be -3 dx. Now, I don't have a -3 out front, but I do have a 6. So if you want to think about this as being 2 times -3 times the quantity 10 minus 3x to the 1/2 dx. Now, to put in the u's, the -3x dx becomes du, so the 2 has to stay there. So I'll have 2u to the 1/2 du. And now I can integrate. Oops. So I'll add 1 to my exponent, which gives me 3/2, and then multiply that reciprocal. So I'll end up getting 4/3 u to the 3/2 from 2 to 3. So now I'll plug back in, and I have a feeling I'm going to run out of room. So I'm going to plug back in my quantity, 10 minus 3x to the 3/2 from 2 to 3. And so now I'll have 4/3. Wait, I missed something back there. As I'm looking at my notes, I noticed I missed a negative. So way back here, I apologize for having to go back, but way back here, when I split the 6 into -3 and 2, it should have been -2. Because -2 times -3 gives me a positive 6. So this 2 should be negative, which makes this negative and this negative and this negative. So I apologize for that. I just forgot a negative. So I'll have -4/3. Now when I plug in 3, I'll get 1 minus -4/3 times, when you plug in 2, that becomes 8. So you end up with 28 over 3. Because this one is -4/3 plus 32/3 gives you 28/3. And again, that's a repeating decimal. So if you want to write it as the repeating decimal with the repeating bar, that's fine. But you should get 28 over 3. And the last one is the trig one. Everybody seems to not do so well with the trig ones. We forget that, trig is a thing. And we usually do well with the algebra part, but the trig gets us. So again, you want to set u as the inside of the function. So u here is going to be 2x, because that's the inside of our cosine function. So du is going to be 2 dx. So I don't have the 2, so I'm going to have to add it in. So I'll have 1/2 of pi over 4 to pi of 2 cosine of 2x dx. Now when I go to write in my u's, I'll have 1/2 is pi over 4 to pi of cosine of u du. So now I'll integrate. So this is going to be sine of u from pi over 4 to pi. And then I'll plug back in my x. So now when I plug this in, I'll have 1/2 times sine of 2 pi minus sine of pi over 2, because 2 times pi over 4. So when I plug pi over 4 in there for x, you get pi over 2. So sine of 2 pi is 0. Sine of pi over 2 is 1. So you end up getting negative 1/2. Don't forget those wonderful minute quiz values. Okay, so sine of 2 pi would be over here. And sine of pi over 2, that would be up here. And remember, sine's your y value, so that's why this one is 0 and this one is 1. Okay? Your homework is a worksheet that is on the classroom with all of the answers worked out. Again, you don't have to turn that into me. That's just for your benefit. Next week, either Tuesday or Wednesday, I'll be posting U substitution problems that you'll have to do and turn in. Okay, so enjoy your weekend. Hopefully the weather's a little bit nicer. Do something nice for your mothers on Sunday, even though you've spent every minute with them for, I don't even know how many days it's been, 6 weeks or whatever. So that's all. Have a great weekend. We'll see you next week.